All right, percent yield calculations. This video is actually going to be a little bit short because we did most of the heavy duty calculations already that will allow us to get the percent yield. Now, in order to calculate the percent yield of a reaction, and once again, we're looking at CH4 plus O2 leading to CO2 and water, you need to actually be told the amount of the product that you actually produced. If you don't know this amount or you're not given this amount, the most you can do is get the theoretical yield, but you can't do anything else beyond that. The percent yield requires that you do know the amount of the substance that you're trying to get the percent yield for that actually was obtained experimentally. Okay, so this will be the amount of CO2 that you or I end up isolating, purifying, and collecting in the laboratory itself. This number may or may not be the maximum amount that we were expecting to get, but that's what the percent yield is going to tell us. How good was our procedure? How good was our technique in isolating CO2 compared to what we should have gotten? All right, so this is the way it goes. With the calculation of the limiting reactant, or the calculation we use to determine the identity of the limiting reactant, we've already gotten the amount of mass of CO2 that is basically the upper limit of what we can get for CO2. This is the theoretical yield. And as long as we start with the limiting reactant and carry the stoichiometry properly, leading up to the product, this amount is what we should get in theory. Now, to get the percent yield, what you do is you divide the actual yield by the theoretical yield and multiply by 100 to tell you what the percentage is of the yield that you actually obtain. And so, in this hypothetical example where I'm saying that 15.7 grams of CO2 is what you actually collected, what you experimentally collected, you basically divide the 15.7 by the 20.6 grams of CO2. You multiply that by 100 and you get a percentage. And yes, the units do cancel out. You end up with only a percentage at the very end. And the percentage of this reaction is in the mid 70s, which is reasonable. It's not a terrible yield. It's not a great, amazing yield, but it is a good yield nonetheless. In some instances, laboratory speaking, uh, or speaking about laboratory, experiences, this type of yield is actually pretty good. You can work with this. This is not a bad yield. Um, but if you end up getting yields that are less than 50%, that's when you have to worry because that's when either of two things are happening. One, your reaction is really not working out the way you expect to work out because maybe the conditions that you are using are not good for that type of reaction. Or two, your conditions are fine, it's your technique that's lousy, and so you're losing a lot of product in the process of trying to purify the substance and isolate it. In which case, you probably need to modify your technique or get, advice on how best to handle the compound to not lose so much of it in the process of purification. Now, another thing that can happen, not always, and at least on paper, this doesn't tend to happen, but sometimes you might see it experimentally, and you might even see it on paper. I'm not going to have proclaimed that this will never happen on paper, but sometimes the percent yield could be greater than 100%. In theory, this should be less than 100% or 100% max. But sometimes you will get a value that is 100, greater than 100% itself. And what that will tell you is that most likely than not, the product that you just got hasn't been purified properly. It has some contaminant in it that is messing up your mass. In the case of hydrate, sometimes you get water products that haven't been removed properly. So perhaps you didn't dry your compound long enough. So you still have a wet sample and the mass of water is contributing to a percentage that is greater than 100. That could very well happen. And just keep in mind that if your percentage is greater than 100, all that's happening is that the experiment is telling you your substance is not pure. But in essence, calculating the percent yield is simply this: actual over theoretical times 100. And because this in and of itself is nothing more than an equation, you could also use this equation to find the actual yield, provided you know the percent yield and the theoretical yield of the substance. So you could easily rearrange this equation to find any of these three parameters. All right, but that's it for the percent yield.